AI models have moved past answering questions in a chat window. They now execute tasks, call APIs, and trigger workflows independently as autonomous actors. Because these systems operate with high autonomy, they introduce distinct risks. In recent surveys, 88% of organizations reported active security incidents caused by unmonitored shadow AI or agents operating with excessive permissions. When teams try to secure these workflows, they often focus on the LLM itself, restricting what the model is allowed to say. But that leaves the execution layer exposed. If an agent is tricked by malicious input, it still has the underlying authority to modify your actual production data. To fix this, we need to move security down to the infrastructure. By the end of this tutorial, we will walk through a complete framework to audit your agent identities, deploy runtime gateways, and safely shut down the forgotten programs lurking in your environment. Step 1 of this framework requires us to run a baseline audit on the agents already operating in your network, focusing closely on their life cycles and how they manage memory. This checklist outlines our starting point. The first requirement is an identity check. You must ensure every single agent has a distinct, traceable ID and a named human owner responsible for its actions. Next, we must constrain memory. Agents maintaining long histories inevitably hoard sensitive customer data and credentials over time. By enforcing a hard cap, like a 20,000 token limit, you force the agent to operate within a defined boundary, preventing dangerous data accumulation. When a workflow pilot ends, there must be a strict kill switch implemented to completely revoke that agent's access. Without that kill switch, you end up with what security teams call an agent graveyard. These are legacy agents that nobody actively monitors anymore, but they still hold live API keys and system permissions. Documenting these orphaned systems and shutting them down removes a massive, invisible attack surface before you deploy any new security architecture. With the legacy systems cleared out, step 2 is properly integrating your active AI agents into your organization's identity and access management infrastructure. On the left, teams mistakenly assign agents to shared service accounts or treat them like human employees. When multiple agents share credentials, tracking actions becomes impossible. The secure approach maps a one-to-one relationship. Every agent needs its own independent, identity-bearing credential. From there, you replace custom, hard-coded authorization logic with strict role-based access control. Access is granted only at the workspace level, giving the agent the absolute minimum permissions required for its immediate task. Enforcing these one-to-one identities ensures perfect audit accountability. Your security team can pinpoint exactly which agent took an action and instantly isolate a compromised unit without breaking the rest of your workflows. Now we reach the core infrastructure upgrade, deploying an AI agent gateway to sit directly between the agent and the external tools it needs. During prompt injection, malicious instructions hidden in documents easily bypass model guardrails, tricking the agent into attacking execution layer targets like databases. An agent gateway physically intercepts every tool invocation, catching the request before the code ever has a chance to execute. The gateway evaluates the intercepted API call against your enterprise policy, generating a real-time risk score based on the specific action the agent is attempting. This lets you configure actionable rules. You can set the gateway to automatically approve high-frequency, low-risk actions, while forcing any high-risk database modifications into a queue for human approval. This dashboard shows the result. Every blocked, unauthorized tool call feeds directly into your security telemetry, creating a permanent, logged audit trail of execution attempts. That same telemetry alerts your team to suspicious behavioral drift. If an otherwise trusted agent suddenly requests unusual permissions, the system flags it immediately. Shifting away from passive safety prompts toward these active execution layer checks is the only reliable way to stop autonomous systems from causing actual data breaches. Once the gateway is live, the final phase is establishing continuous monitoring and automated testing to keep the environment secure as your deployment scales. AI systems reason dynamically, which makes static point-in-time security reviews practically useless. The agent's behavior shifts every time its context changes. To handle this, you need to build automated red teaming directly into your integration pipelines. This continuously subjects your agents to simulated prompt injection attacks, finding vulnerabilities before production. This slide outlines the baseline for bringing zero-trust architecture into a multi-agent environment: strict least privilege scoping, short-lived credentials, and explicit agent-to-agent authentication. That last point requires special attention. When one autonomous agent attempts to task another, the system must require explicit verification for the handoff, rather than trusting the internal connection by default. Combining these immutable audit trails with a strict zero-trust architecture takes AI agents from unmonitored liabilities and turns them into trackable, strictly governed assets. We have now mapped the complete transition from relying on passive guardrails to enforcing active execution layer security. Your enterprise system is now structured around fully audited agent identities, runtime gateways intercepting tool calls, and automated red teaming keeping defenses sharp. You have neutralized the dual threats of unmonitored shadow AI and cleaned up the dormant access keys left behind in the agent graveyard. To start mapping your own agent inventory and securing your execution layer, download the CISO Agent Audit Checklist linked in the description below.